proportions in triangles today. So we are going to look at different types of triangle theorems and how to set a proportion within a triangle. First one we are looking at is the triangle proportionality theorem or the side splitter theorem. So this happens whenever you take a triangle and you basically cut through it and you split the sides into two proportional pieces. The thing you have to pay attention to is the parallel markings. You need to have parallel markings or something like corresponding angles in order to show that the lines are parallel in order to create proportionality within the theorem. So what this theorem basically says, and write this down, is if segment BD is parallel to segment AE, then you can state a few different proportions. So for example, proportion number 1, you could say AB and BC are proportional to ED and DC. You could say that AB over ED is proportional to BC over DC. So you could go across left to right, then left to right. You could also do the bases. So you could do BD, which we have done this one before, is proportional to BC. So the smaller triangle base is proportional to the smaller triangle side. And that would be congruent to the big triangle base, AE, is proportional to the big triangle side, AC. And of course, you could do that for both sides of your triangle. So you could do BD over the right side this time, over DC, is proportional to AE base over EC, right side. Okay? All right, the converse of the side splitter theorem, you guys should remember what converse means, is that if the two sides are proportional, then the third line in between the two triangles is going to be parallel. All right, let's try and do an example here. So we've got find the value of x. First thing we're going to look for, we have those parallel lines. Excuse me, I need a drink. All right, with those parallel lines, we can set up a proportion as long as you stay consistent. So I'm going to go top to bottom. So I'm going to go 24 over x equals, then go back to the top, 32 over 40. Cross multiply. 32x equals 960. So x equals 30. Okay, over here, once again, we've got those parallel lines. And I am going to go left to right this time. So I'm going to do x plus 6 over x plus 1. So I'm going to do the bottom left to the bottom right side. And I'm going to go back to the top left. So x over x minus 3. All right, I hope you are ready because we're going to bring back in a little bit of foiling and stuff here. So whenever we cross multiply, I'm going to write it out instead of actually doing it in my head right now. So x times x plus 1, so we're going to have to distribute there. And then x plus 6 times x minus 3, sorry. And then we're going to distribute and FOIL. So that would give us x squared plus x equals, then FOIL the right side. So first, it's going to give us x squared, outside, negative 3x, inside, plus 6x, and last, minus 18. So then once you have that, you are going to solve. So I always start with your biggest exponents, so your x squareds. So I'm going to try and get rid of those or move them together. So I'm going to subtract the x squared, subtract the x squared. What happens? They cancel. So you're going to be left with x equals And then I'm going to go ahead and put these two together here. So that's going to give me a 3x minus 18. So then we can keep solving this here. I'm going to add the 18 to the left side. So I'm going to add 18 over here. And I'm going to subtract x over here at the same time. So that's going to give me 18 equals 2x. And then x equals 9. The reason I did that is because I don't want to deal with the negative 18. So I just moved the negative 18 to where it would stay positive. All right, flip the page. Let's do examples 3 and 4. On example 3, you have two variables defined this time. So you have x and y. I've got all sides figured out except for, zoom in here. Hopefully you guys see that this side doesn't have a number. But hopefully you can pick the fact that if you take 15, the whole side, subtract 9, that would give you 6 for the remainder of that side right there. I'm going to do that before I start the problem. And then I'm going to solve for x first. So I'm going to do x over 6, so left over right, equals 5 over 9, left over right. I'm going to come down here and set that proportion up. So once again, left over right, x over 6 equals 5 over 9. And then 9x equals 30. So x equals 3.3 repeating. All right, and I'm going to delete or erase these highlights. Now I'm going to do y now. So y is on a base. So whenever we're talking base, we have to go small base, okay, to small triangle side. And then we go big base to big triangle side. So whenever we set that up, it'll be small base 6 over small triangle side 9 equals big base y over big triangle side 15. Then we cross multiply, 9y equals 90. So y is going to equal 10. Okay. All right, let's do that base thing again. So once again, we're going to go small base. So that's x plus 2 over small triangle side. So that would be your 10 here. And that's equal to big base, x plus 14, over big triangle side. Well, guys, the big triangle side here is going to be x and 10 together. So the big triangle side, we're going to have to add them up, x plus 10. Okay? And then you notice whenever we cross multiply, we're going to have to do some foiling and stuff again. So I'm going to do 10 parentheses x plus 14 equals x plus 2 times x plus 10. So we get 10x, plus 140 whenever we distribute. And then FOIL, we get x squared plus 10x plus 2x plus 20. So this time, I'm looking at my x squared here. I don't have another x squared to combine it with. If you don't have another x squared, in order to cancel the x squareds out, you're going to have to solve using factoring. So if you only have a single x squared, we're going to have to factor here. So in order to solve by factoring, we have to get the quadratic equation equal to 0. So in order to do that, we need to move this stuff on the left, or one of the sides, away to the right side. So that way we get 0 on one side. So I'm going to subtract 10x and then subtract 140. I'm doing this with what is similar. So I'm like combining like terms. So we get 0 on the left because everything cancels. We get x squared. The 10x minus 10x canceled. So we have plus 2x. And then the 20 minus 140 is a negative 120. Once we get to this point, yes, we have to factor. So we are going to have to look and say 0 equals, open up these parentheses, binomials. What two numbers, what two factors multiply to give us negative 120 and add to give us a positive 2? So don't make this too difficult. 120, if you take the 0 away, that means you're taking a 10 away, and you'd be left with a 12. So I'm going to use 10 and 12. Reason being is if you put those two together, that would give you 2. Now, x, you just need to figure out the proper plus and minus sign. We want a positive 2. So that means we want our bigger number, bigger factor, to be positive. So I'm going to put the plus here with the 12, minus here with the 10. So that would, if we multiply negative 10 times positive 12, we would get a negative 120. If we added negative 10 plus 12, that would give us positive 2. Now we have to solve these. So split them. X minus 10 equals 0. X plus 12 equals 0. And solve them. So x equals positive 10. X equals negative 12. Obviously, in geometry here, you can't have a negative number. So if we were to plug back in negative 12 up here to the x, that's not going to give us positive side lengths. So we can cross negative 12 out, meaning our answer for x is 10, positive 10. All right. Corollary to transversal proportionality. Whenever we have more than two transversals or more than two parallel lines, we can cut them by transversals, meaning that we can create proportions within the sides here. So for example, you could do AB to DE. So once again, left to right, this is just not inside of a triangle. And then BC to EF. So you could do left to right, just like we did in a triangle, but it doesn't always have to be inside of a triangle. You can have 3 parallel lines like this and still complete the same proportion. Or if you don't want to go left to right, you can go top to bottom. So you can go AB to BC, and then you can go DE to EF. Should give you same proportion. All right, let's practice it. The segments joining the sides of trapezoid RSTU are parallel to its bases. Find x and y. So we've got 4 parallel lines within our trapezoid here. We need to find x and find y. So I'm going to look up here at the top, and I've got a good solid ratio without a variable. So 6 to 5, left to right. I'm going to set that equal to left to right, x to 12. And solve. 5x equals 72. So x equals 14.4. Then you also have to do y. So I'm going to set up the same left to right, 6 to 5. And then that is going to be left to right for the y, 9 to y. So that would give us 6y equals 45. So y equals 7.5. And that's about as simple as that one gets. Okay, there's nothing really tricky to go along with multiple parallel lines there. All right, flip your page. If you were to set up your proportions without using numbers, you need to be able to match them. So which statements are true? PQ over QR. So we're going top to bottom here. So if we kind of look at it, PQ to QR, and then as long as we go UT to TS, so we went kind of like left to right, moved along, then that works. So this one is good. Next one, TS to UT. So this time we went right to left, same as QR to PQ. So that one works good. We went right to left both times. So we're going to dot that one in. Next one, QR to RS. So that's the base. TS to RS. So that one's not going to work because you were going to the same base, top to base, bottom to base, and you didn't include the side to side. And the last one, PQ to UT. So this one we're going top to bottom. And then PR, so that's the whole top, to US, the whole bottom, which would be just fine. As long as you use both sides. Okay, so those are your working proportions. All right, last topic here, triangle angle bisector theorem. So if a ray bisects an angle of a triangle, remember that word bisect means to cut in half. Then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So what we're looking at here is you need to draw your little heart. Okay, if it's an angle, triangle angle bisector, we bisect that top angle and we create that heart, two congruent angles there. So if angle A, B, C, try that again. Angle ABD is congruent to angle CBD, so that heart we created, then you can set up two different proportions. So you could go left side of the triangle AB to its base of the left triangle AD is proportional to CB, the right side, to CD, the right base. Or you could do second proportional would be AB. You could go left to right. So the left triangle side to CB, and then the left base, AD, to the right base, CD. You could set up either of those proportions. So let's try it. Find the value of x. Well, first off, we've got a left side, a right side, and we got a left base, and no right base. So how do we find the right base here? The whole base is 15, and if we take away the left base, we should end up with the right base. So over here, that would be 15 minus x. So now we can set up our proportion. I personally don't care which way you set it up. So I'm going to do left side to left base first, kind of like the first proportion we just showed you. And then on the next one, I'll do left to right, base left to right. All right, so 10 to x, left side to left base, equals right side to right base. And then cross multiply, that would give you 150 minus 10x equals 12x. Add the 10x over, 150 equals 22x. So x equals 6.8. Pretty simple. Number 8, same thing. Don't have the right base here, so I'm going to put 40 minus x, total minus left base. This time I'm going to go left to right. So I'm going to go left side to right side, and then I'm going to go left base to right base. Cross multiply, get 24x equals 1280 minus 32x. Add your 32x, that'll give us 56x equals 1280. Divide x equals 22.9. All right, that's the end of notes. If you have any questions, don't forget to email. If you need to rewatch it. You learned 3 different theorems today. And then get started on your worksheet. If you need help on the worksheet, you can ask. See ya.